curve fitting. Curve fitting is the process of constructing a curve or mathematical function that has the best fit to a series of data points. So we will play with another data points, okay, possibly subject to constraints. So in the interpolation describe the linear interpolation between 2 points. So you have this line, several lines here. Each line that can be formulated as fx equal to ax plus b. So in order to get the approximation for the entire range, the summation for each line need to be done where it does not seem well and might give a tedious calculation. Meanwhile, in curve fitting, it will describe how the same scatter data points can be fitted in the best approach by sketching a straight line, this straight line, fx equal to ax plus b, okay, to obtain the estimation for the entire range. So now we want to find this straight line equation when you are given some data points. Okay, so there are two types of curve fitting. The first is the least square line method, and the other one is the least square method, polynomial regression. So this is y equal to ax plus b, y equal to a plus b, x1 plus cx2, and for polynomial regression, a plus bx plus cx squared. We have x squared here. As you know, this is y equal to a plus bx. So this a is the y-intercept, then b is the slope. The slope of the line. A is the y-intercept, where the point at which our graph intercept the y-axis, and b is the slope. Okay, so first let's look at the linear regression. Fx equal to a plus bx. Okay, the least square line method basically uses a straight line. Okay, so this is the straight line equation to approximate the raw data set x1, y1, x2, y2 until xn, yn, where n is greater or equal to 2. The best fitting curve fx has the least square error. Okay, so this is how to calculate the error. Okay, summation. Okay, this sigma indicates summation. Okay, from I equal to 1 to n, yi minus a plus bxi squared. With a and b are unknown coefficient, while xi and yi are given. So xi and yi are all the points given the raw data set. So how to find a and b? This is the unknown coefficient. So a, this is the formula for a, and this is formula for b, where y bar and x bar are the average of y and x. And the summation are defined by this sx, sy, sxy, and sxx. So let's try this example. You fit a least squared regression line for the data below, then calculate the overall error. Okay, so we have 11 points. This is x, and the second row is values of y. So in this case, n is equal to 11. N is the number of points that we have. Number of points that we have. So here, okay, let's find a. So a is equal to y bar minus b x bar. So you know that y bar and x bar are average of y and x. This is your x and y given in the question. So the summation of x is just the total 0 plus 2 plus 3 until 10. So you will get 55. And the summation of y, okay, sum up all these, you get 50. And then just square the value of x here, square it. Then sum all this, you will get 385, and x times y, all these, okay, you will get this value and sum this up, you will get 358.1. This is equal to this, right? This value. Summation of x here 55. Summation of y 50. Okay, and again n is equal to 11. Okay, number of points. Okay, xi squared. Xi squared, this is x summation of xi squared 385. And summation of xi, you have to square it. Okay, summation of xi, you have to square 55. So from this you can find your b and also a. Okay, normally you just find this b and then you can use this formula or this. It's up to you. This is the details that I just explained just now. So this is your n. This is the summation xi, yi. Okay, here. And then summation xi, summation yi. Okay, 55 and 50 and is equal to 11. Xi squared, summation of xi squared 385. 3x5, summation of xi is equal to 55. Then don't forget to square it. And then simplify this. You will get b is equal to 0.9827. Then after you get b, you need to calculate the value of a, y bar minus b x bar. So this is your y bar. The average of y 50 divided by 11. Number of data 50 divided by 11 minus this is value of b and this is average of
X bar.
55 divided by 11. So you get this a. So this is your y equal to b x plus a. Okay. So this is your b and this is your a. Let's calculate the error. Okay, so let's see what is the formula for error. yi minus a plus b xi. Okay, calculate one by one. Okay, this is for the first value. Okay, x0, y0. A0 minus, okay, the value of a and b are fixed for each point. So you can use this value, b and a. This is a, b times xi. So this is your first value. This is how you get 0.368. And then you need to square it. Okay, just square this value. Okay, so you will get 0.1354. So the square of error, this is the value 0.6546. And the error is the square root of this value 0.8091. So you can try this. You just play around in the Microsoft Excel. Just put this value x and y. So this is the given value. And then find x squared, x times y. This is for error. yi minus a plus b xi. And then the value of the square. Find the summation each of these. So now let's look at this exercise, or maybe you can try later. You can refer this example that we just discussed just now. Then you can try this exercise number 1 and 2. Check whether you get the same answer. Okay, next is the least square method, polynomial regression. So some engineering data, although exhibiting a marked pattern, is poorly represented by a straight line. Okay, for these cases, a curve would be a better suited to fit the data. So one method to accomplish this objective is to fit polynomials to the data using polynomial regression. So just now we have to find the straight line. So now we will get the curve y equal to a plus bx plus cx squared. Okay, polynomial curve fitting. So this is your formula for summation y, summation xy, summation x squared y. And this is the formula for error. Fix a least squared polynomial regression to the data below. Then find f negative 1.5. This is your x and this is your y. Y equal to fx. 1, 2, 3, 4, 5, 6, and 6. Write down in the table form x and y given, okay, and the summation x times y, here x times y, okay, for each of the points xi squared, okay, just square this value, you get this xi squared yi, square this times 2y, so you get this, and then xi cube, x power of 3, negative 3 power of 3, you get negative 27. And then xi power of 4, negative 3 power 4, you get 81. Okay, so you have to find all this value and then sum it up together, the summation of each of these, and then substitute all this value into your formula. From this formula, you need to find the value of your A, B, and C. So you know the summation y here is equal to 14. Here 14. Okay, just substitute all this together. Then you get 3 equations with 3 unknown. A, B, and C. A, B, and C are the unknown that you need to find. Okay, you have to solve this system to obtain the value of A, B, and C. Okay, so how to get the value of A, B, and C? You can write all these equation in matrix form. Okay, 6, negative 3, 19. 6, negative 3, 19. Negative 3, 19. Negative 27. 19, negative 27, 115. A, B, C here equal to 14, negative 12, 74. Okay, 14, negative 12, 74. You can write in the matrix form. Then you can solve this. Okay, you can use any method to solve this. Solving a system of linear equation. So you can get this A, B, and C. So the least squared quadratic equation is, okay, so the formula, here this is the formula, A plus BX plus CX squared. So this is your A, B, C. So this is A plus bx plus cx squared. So A, B, and C. This equation can be written as fx equal to 0.4286 plus 0.375 x plus 0.6607 x squared. So remember, we have another question. Find f negative 1.5. So when x equal to negative 1.5, so f negative 1.5, just substitute negative 1.5 into your x. Here, the x squared. Then simplify it. So f negative 1.5 is equal to 1.3527. This is the first answer for the first question and the second question. Okay, so this is another exercise. You can try later. This is the given answer. Fit a straight line and quadratic polynomial to the following noisy data by using least squared method. Okay, so you have 1, 2, 3, 4, 5 data. So n equal to 5. This is the value of your x and this is your y. X squared, x times y, and then find the summation and substitute in the formula. So you will get your b, and from your b you can get your a. Substitute a and b into your linear regression straight line. So you get this equation of straight line. So this is your answer. So that's all for today.